Welcome back, everyone, to another deep dive. Today, we're going on a journey to the cutting edge of data storage, and I'm talking molecular hard drives.
Yeah, molecular hard drives, definitely mind-bending concept.
It is, it is. But that's why we're here, right? To
Yeah.
break it down, explain what it is, why it matters, and the potential impact it could have.
Right, exactly. It's a pretty exciting area of research for sure. We could be talking about a big, maybe even huge paradigm shift in how we store and even access information.
Okay, so let's start with like the basics. So imagine shrinking like a hard drive, shrinking it down to the size of a molecule.
Yeah.
That's basically what we're talking about here, right?
Essentially, yeah, that's it. But instead of those magnetic platters, those spinning disks, these hard drives would use molecules, like specially designed molecules, to store the data. And get this, each molecule could store multiple bits of information.
Wait, hold on. Multiple bits per molecule? How is that even possible?
It all comes down to manipulating the electrical properties of these molecules. You can
Hmm.
kind of think of it like a microscopic switch.
Okay.
Yeah, so by changing like your arrangement of atoms within the molecule, scientists can control its electrical conductance. That's basically how easily electricity flows through it.
So instead of just a 0 or a 1, you could have multiple conductance states, and those would represent different combinations of bits.
Exactly. Yeah, it's like having a switch with multiple settings instead of just on or off.
Okay, I think I'm following so far. But to read and write this data, to actually interact with these molecular switches, how do they do that?
Well, they use a tool called a conductive atomic force microscope. It's often just called a CAFM.
A CAFM. So they're literally poking individual molecules to store data. That's incredible.
It is pretty incredible, really. It's all about precision at the nanoscale.
But what are these molecules actually made of? What makes them so special, so unique for this kind of data storage?
They're made up of some pretty fascinating components. There are redox active transitional metal cations, organic ligands, and driftable halogen anions.
Okay, I'm gonna need a translation on that one. I'm not a chemist.
Right, sure, no problem. Think of it like this. You have a central metal ion, kind of like the core of the molecule, right? And then you have these organic molecules and charged atoms kind of surrounding it, like a shell almost. And by changing the arrangement and the interaction of these surrounding components, you can alter the molecule's electrical conductance and therefore its ability to store data.
So it's like each molecule is like this tiny, like customizable circuit,
Yeah.
kind of, and it has different levels of resistance.
That's a great analogy.
Okay, I like that.
Mhm.
I can picture that. But because these molecules are so small, I mean, how much data can we actually store? What are we talking about here?
Oh, we're talking about an incredible amount of data, really. You can pack a huge number of them into such a tiny space. We're talking about potentially surpassing the storage density of even tape archives.
Hmm.
And those are the gold standard right now for high density storage.
That's a game changer. I
Yeah.
mean, imagine storing entire libraries or massive scientific data sets all in a device the size of a fingernail. The implications are huge.
Oh, they are. They are. And that actually brings us to another potential advantage of this technology, the power consumption. The
Mm.
process of reading and writing data at the molecular level is incredibly energy efficient.
Really?
Yeah, we're talking picowatts per bit. That's practically nothing compared to traditional storage methods.
That's amazing. But wouldn't there still be like a physical disk involved? Wouldn't spinning that disk require energy?
Yeah, you're right. That's a really good point, and it highlights a key thing here. The research so far has mostly focused on the read and write aspect of molecular storage, the energy required to spin a physical disk. That would be a separate thing to think about, and potentially a challenge to overcome.
So it's not a completely energy-free solution. Are there any other potential hurdles on the horizon? Anything else we need to think about?
Well, one major challenge is the lifespan of the CAFM tip, the one used to read and write the data. These tips they're incredibly delicate and they wear out relatively quickly.
So it's like having a pen that runs out of ink after writing just a few words.
Yeah, exactly. For molecular hard drives to be practical, we need a much more durable tip. Otherwise, you'd be constantly replacing them. which wouldn't be very efficient.
Right. Yeah, that makes sense. But even with these challenges, even with these hurdles, I mean, the potential of molecular hard drives is pretty mind-blowing. It's like the floppy disk of the future.
It's a captivating concept, for sure.
It is. And speaking of data storage, it's a good time to mention our sponsor for this deep dive, Stonefly. They're an industry leader in enterprise-scale storage solutions, and that includes ransomware protection.
Yeah, if you're dealing with large amounts of critical data, you definitely want to check them out.
Absolutely. I mean, data security is more important now than ever, and Stonefly offers a really robust suite of solutions to meet those needs. They provide everything from enterprise scale storage, backup and disaster recovery, AI storage, even cloud solutions. And for those of you who are especially concerned about data security, they offer top-notch ransomware protection. You can contact Stonefly at sales@stonefly.com to learn more about their offerings.
Now, going back to those molecular hard drives and kind of their potential impact on different industries.
Yes, we were talking about their impact. Imagine a world where massive data sets, everything from scientific research to entire libraries could be stored in a device the size of a coin.
Okay, now that's a future I want to live in. But it makes you wonder, what would the impact be on various industries? How would personal computing, how would healthcare, how would even entertainment be transformed by this kind of technology? Those are all excellent questions, and it brings us to a really crucial point. This technology, it's still in its early stages of development.
Right. So we're talking about potential here, not something you can buy off the shelf just yet.
Exactly, yeah. There are still significant technical hurdles to overcome, like that CAFM tip lifespan we mentioned.
Right.
But the research is progressing really rapidly, and the possibilities are truly exciting.
It's like we're on the cusp of a whole new era of data storage.
Yeah.
And I, for one, can't wait to see what the future holds.
Yeah. Before we get too carried away dreaming about the future, it's important to acknowledge that, this technology is still in its very early stages of development.
Right. We've talked about the potential benefits, like massive storage capacity and incredibly low power consumption. But we also need to consider the challenges.
Exactly. The CAFM tip lifespan is a major hurdle, and there are other factors to consider, like the stability of these molecules in different environments.
So temperature, humidity, things like that could affect their ability to store data reliably.
Precisely. And we also need to think about the potential for data corruption. With such tiny structures involved, even the slightest disruption could potentially scramble the data.
So a stray cosmic ray could potentially wipe your entire hard drive.
It's a possibility, although researchers are working on ways to mitigate that risk. For example, they're exploring error correction techniques and more robust molecular designs.
Well, that's reassuring. It sounds like there's still a lot of work to be done before molecular hard drives become, mainstream.
Absolutely. But despite these challenges, the potential benefits are so enormous that research and development are moving forward at a rapid pace.
And speaking of pushing the boundaries of data storage, this is a perfect time to remind our listeners about Stonefly. They're at the forefront of enterprise-grade storage solutions, offering a wide range of products and services that are built for the future.
Yeah, whether you need enterprise-scale storage, backup and disaster recovery, or AI storage, Stonefly has you covered. And with their expertise in ransomware protection, you can rest assured that your data is safe and secure.
To learn more about their cutting-edge solutions, be sure to contact them at sales@stonefly.com. You won't be disappointed.
Now let's dive a little deeper into the science behind these molecular hard drives. How do they actually work at the atomic level?
Yes, I'm dying to explore the inner workings of these tiny data vaults. Let's unlock the secrets of molecular storage.
All right, so you want to get down to the atomic level.
Let's do it.
Okay. Well, remember those complex terms we mentioned earlier, the redox active transitional metal cations, organic ligands, and driftable halogen anions.
Yeah, those were a mouthful. It's like the chemistry textbook just exploded in here.
It might sound a little intimidating, but it's actually quite elegant. You see these molecules, they're like tiny, intricate structures with a central metal ion at their core.
Okay.
So
Yeah.
think of that metal ion as like the heart of the molecule.
Okay. So I'm picturing like a tiny little metal heart, all right?
Right, right. Now surrounding that heart are these organic molecules and charged atoms, kind of like a protective shell.
Yeah.
And here's the key, the arrangement and interaction of these surrounding components that directly influences the molecule's ability to store data.
So by changing the arrangement of these components, you can change how the molecule stores information.
Exactly. Remember how we talked about different electrical conductance states? Well, those states are determined by the specific configuration of these surrounding molecules and atoms. It's like building a tiny intricate circuit where the level of resistance can be finely tuned.
So each molecule is like a customizable circuit, and by tweaking its configuration, you can control how much data it can store.
You got it. And the beauty of this is that these molecules are incredibly small. I mean, we're talking about manipulating matter at the atomic level, and this means you can pack an astounding number of these molecules into a tiny space, leading to unprecedented storage densities.
It's mind-boggling to think about like controlling data storage at such a minuscule scale.
It really is. Is it to give you an idea of the precision involved here? Scientists use that CAFM we talked about earlier, the conductive atomic force microscope, to apply a specific voltage and rearrange those surrounding components. It's like using a submicroscopic tool to build a data storage structure atom by atom.
So they're essentially manipulating the building blocks of matter to store information.
Exactly. And the potential implications of this are huge. Imagine a world where you could fit your entire digital life, your photos, videos, music, documents, everything onto a device smaller than a grain of rice.
Okay, that's a future I can get behind. But before we get carried away with all the amazing possibilities here, let's come back to those challenges we discussed. What about that CAFM tip wearing out? How big of a problem is that?
It's a significant hurdle, that's for sure. You see, these tips, they're incredibly sensitive, and the constant contact with the molecules causes them to degrade over time. It's like trying to write a novel with a pencil that keeps breaking its lead.
So frequent tip replacements would be like a major logistical and cost barrier.
Exactly, and that's not the only challenge. We also need to consider the stability of these molecules in different environments.
You mean things like temperature and humidity could affect their ability to store data reliably?
Precisely. Imagine leaving a traditional hard drive out in the sun or spilling water on it. Not a good idea.
Right.
Well, molecular hard drives would be even more sensitive to such environmental factors. Maintaining a controlled environment for these devices would be essential for their long-term performance.
That makes sense. So we have the tip lifespan, and we've got environmental sensitivity to consider. Are there any other like red flags on the horizon?
Another concern is the potential for data corruption. With such tiny structures involved, even the slightest disruption could potentially flip those molecular switches and scramble the data.
So a stray cosmic ray could potentially wipe your entire hard drive. That's a bit unsettling.
It's a possibility, although researchers are actively working on ways to mitigate that risk. They're exploring error correction techniques and more robust molecular designs to make these drives more resilient.
That's good to hear. It sounds like there's still a lot of research and development needed before molecular hard drives become a practical reality.
Absolutely, but the potential benefits are so significant that the research is progressing rapidly. It's an exciting field to watch.
Speaking of exciting developments in the world of data storage, this is a great time to mention Stonefly, our sponsor for this deep dive.
They are truly a leader in the field, providing enterprise-grade storage solutions that are designed for the future.
If you're looking for reliable, secure, and cutting-edge storage solutions, Stonefly has you covered. They offer a wide range of products and services from enterprise-scale storage to cloud solutions, and their expertise in ransomware protection is second to none.
Protecting your data is more crucial now than ever before, and Stonefly offers the peace of mind that businesses need to thrive in this data-driven world.
To learn more about their comprehensive suite of solutions, contact Stonefly at sales@stonefly.com. You'll be glad you did.
Yeah.
Now let's shift gears a little bit and talk about the potential impact of molecular hard drives on different industries.
Ah, yes, the possibilities are truly fascinating. Where shall we begin?
Let's start with healthcare. Imagine being able to store a patient's entire medical history, including high-resolution images and genetic data on a device smaller than a grain of rice.
It would revolutionize personalized medicine. Doctors could access a patient's complete medical record instantly, leading to more accurate diagnoses and personalized treatment plans.
And think about the implications for medical research. Scientists could store and analyze vast amounts of data from clinical trials to genomic sequences, leading to breakthroughs in disease prevention and treatment.
It's mind-blowing to consider the potential for accelerating medical advancements, but the impact wouldn't stop there.
Let's move on to another field that could be transformed, scientific research. Imagine storing massive data sets from particle accelerators, astronomical observations, or climate models.
It would be like giving scientists a whole new universe of data to explore.
Exactly. And the speed at which they could process and analyze that data would be unparalleled. It could lead to breakthroughs in fields ranging from astrophysics to material science to climate change research. The possibilities are truly endless. And what about personal computing? Could we see laptops and smartphones with molecular hard drives?
Absolutely. Imagine a smartphone with the storage capacity of a supercomputer. You could carry your entire digital life, your photos, videos, music, documents, even your entire operating system, all in your pocket.
It would change how we interact with technology, how we create and consume content, how we connect with each other. It would be a paradigm shift. And what about entertainment?
Imagine streaming ultra high definition movies and playing immersive virtual reality games without any lag or buffering. It would be a truly seamless and an immersive experience.
It sounds like something out of a science fiction movie.
It does, doesn't it? But the reality is that this technology is closer than we might think, and the impact could be even more profound than we can imagine.
Okay, my mind is officially blown. But let's bring things back down to Earth for a moment. But before we get too carried away dreaming about the future.
Right. It's important to remember that this technology is still in its early stages of development, and there are those challenges we discussed.
Exactly. But even with those challenges, the potential is incredibly exciting.
It is. It's a journey of discovery and innovation, and we're just at the beginning. Who knows what incredible breakthroughs await us in the years to come.
It really is amazing to think about how this technology, how it could reshape our whole relationship with data.
Yeah, it's not just about, fitting more data into a smaller space. It's about fundamentally changing how we even think about data storage. Right now we're constrained by physical limitations. Hard drives have a certain size, servers take up space, and even cloud storage relies on these massive data centers.
It's true. We tend to think of data in terms of physical space. Like gigabytes or terabytes on a hard drive.
Right, but molecular storage has the potential to break free from those physical constraints. Imagine a world where data storage is measured in terms of molecules or even atoms. It's a whole new way of thinking about information.
It's like moving from the realm of physical storage to like the quantum realm of data. It's almost abstract.
Exactly, and that shift in thinking, it could have profound implications for how we design and use technology. Imagine devices and systems that are no longer limited by the physical size of their storage components.
It opens up a whole new world of possibilities. But let's come back down to Earth for a moment. We talked about the potential, the challenges, the impact on various industries. But what about the timeline? When can we realistically expect to see molecular hard drives hit the market?
That's the million-dollar question, isn't it? It's always difficult to predict an exact timeline for emerging technologies. there are still significant technical hurdles to overcome, and the research is ongoing.
So we're not talking about like next year or even the year after.
Probably not, but given the rapid pace of progress in nanotechnology and material science, I wouldn't be surprised to see like working prototypes within the next decade.
That's sooner than I expected. It seems like science fiction is becoming reality faster and faster these days.
It's an exciting time to be alive, that's for sure. And speaking of exciting developments, it's a good time to remind our listeners about Stonefly, our sponsor for this episode.
They're an industry leader in enterprise grade storage solutions, and they're always pushing the boundaries of what's possible.
If you're looking for storage solutions that are built for the future, Stonefly is the way to go. They offer a comprehensive suite of products and services, including enterprise scale storage, backup and disaster recovery, AI storage, and cloud solutions.
And they're experts in ransomware protection, which is more important than ever in today's world. You can rest assured that your data is safe and secure with Stonefly. To learn more about their cutting edge solutions, be sure to contact them at sales@stonefly.com.
Now, before we wrap up our deep dive into molecular hard drives, I want to leave our listeners with a final thought-provoking question. Imagine a world where data storage is virtually limitless and incredibly cheap.
Okay, I'm intrigued. Lay it on us.
How would that fundamentally change our relationship with information? How would it impact our society, our culture, our very way of life? It's something to ponder as we stand on the cusp of this technological revolution.
Wow, that's a really profound question. It makes you think about the bigger picture, beyond just the technical aspects of data storage.
Exactly. The implications of this technology, they extend far beyond just bits and bytes. It has the potential to reshape how we interact with information, how we learn, how we communicate, even how we think.
Well said. It's a fascinating journey we're embarking on, and I for one am eager to see where it leads.
As am I. It's a testament to human ingenuity and our relentless pursuit of pushing the boundaries of what's possible.
And on that note, I want to thank our listeners for joining us on this incredible deep dive into the world of molecular hard drives. It's been a pleasure exploring this mind-blowing technology with you.
It's been a privilege to share these insights.
And a huge thank you to Stonefly for sponsoring this episode. Be sure to check them out at sales@stonefly.com for all your enterprise storage needs. Until next time, keep exploring, keep learning, and keep diving deep.
We'll see you on our next deep dive.